Hello, this is Marcus from CyberDog. Today you're looking at the iPhone 5 backlight repair video. So in this video, it's going to demonstrate how to remove an iPhone 5 backlight coil, backlight IC, and 3 backlight filter for iPhone 5. So first, you put some no-clean gel flux on either side of this is the iPhone backlight coil for iPhone 5. So you put some gel flux on either side of the connections. Then you turn your soldering iron with the appropriate size of the tip to roughly 300 to 350 degrees Celsius. You can go up a little bit higher as well, as go up as high as 400 degrees Celsius, as long as the tip itself is not actually 400 degrees Celsius. Basically, you want to melt the lead-free solder that's initially on the coil, on this logic board, which will melt at around 230 degrees Celsius. So anything above that will be fine. 300 will be ideal. So what I have on my soldering iron in this video is that some of the low temperature CyberDog SMD alloy is designed for desoldering. This alloy melts at much lower temperature. So when you mix the lower melting solder alloy with the initial logic board alloy, the solder, once you mix it, it can become easier to remove. And the reason you want to do this is because you don't want to continuously heat up the logic board on both sides of the solder connections for too long. It can damage the neighboring components. So that was a drop of the, you see how mellow and liquid-like this alloy is? Because it has a much lower melting temperature. In order for this to work, your soldering iron actually have to melt. You have to maintain the heat to at least 250 degrees in order to melt the original solder. Once that's mixed, then the combined melting temperature will be much lower. Actually closer to less than 100 degrees Celsius once it's combined. So I've done that on one side, and now I'm doing the other side. It's okay if you get some of this solder onto the component. Well, you don't want to do it on purpose and get it into the neighboring component, but if you did it accidentally, it's okay. You can always clean them afterwards. Fasting forward, because the surface area of the solder that's done on the logic board on this coil is quite large. The soldering iron I use had a difficult time to assess the angle enough to create enough heat to the original solder. So that's why now in the video you see I'm putting on Kapton tape. Kapton tape is designed to withstand 268 degrees Celsius without actually getting deformed and melting. It's a special type of polymer. It serves as a heat sink. It's almost as a shield protecting whatever components tape underneath. You can also use aluminum tape for this, but I just happen to have Kapton tape. That's why it was used. Also, Kapton tape, you are able to see what's going on happening underneath the tape because it's translucent. So the reason I'm putting the Kapton tape around the backlight coil is because I'm going to blast it with heat gun. Don't really need to do this step, but I just figured for the tutorial, it's a better, more protective way for you to remove components. Again, you want to always apply ample amount of good quality flux to the area you're working on. So what you see now, the metal part, it's the nozzle from the heat gun. Since on the both side, I already have the low melting cyber dark alloy SMD reward kit. The heat gun doesn't, it's very difficult for you to actually damage the component when you do this. I would say it doesn't really matter on how high your heat gun is at, as long as you control the board temperature. So setting it at 350 to 400 degree or even 450 degree for your heat gun is fine. Because what's gonna happen on board, the temperature is not actually at 400. It's only the heat gun core that's 400. Also, before you do this, it would be a good idea to preheat the board to 100 degrees Celsius if you have a preheater. I did not use a preheater in this repair, but that will really help for the speeding up the repair process. You can also preheat the board the way I'm doing in the video right now, just heating it, letting it go, heating it, letting it go. That'll heat up the board too. Again, you always want to supply the flux. Once the flux is dry, you are running dangerously at higher temperature than you wanted for the solder to flow, then getting to the range of damaging the components. Flux serves almost as a temperature buffer to absorb the excess kinetic energy from the heat gun. Hence, the temperature will only rise as high as the flux vaporization point. And this particular flux vaporization point is just a few degrees above the lead-free melting solder. So it will vaporize at 270 degrees Celsius. Okay, going back using the soldering iron. So the heat gun method was proven too slow. Forward because the heat gun station I was using, the temperature wasn't high enough to remove this part. So this is a same old method using the soldering iron on both sides. And as you can see, the coil comes off quite easily if you supply enough heat. As you see this padding, it has a pretty large surface area underneath. That's why there was and the coil is pretty thick, so there was some difficulty using the heat gun earlier for deeper penetration of the heat. Soldering iron will probably work better if you don't have a preheater. However, if you do have a preheater and an infrared station, that will also work. I'm putting in the video right now. I'm putting back one of the capacitor that flew off earlier in the repair. So if you do damage any components, neighboring components, for example, like they fly off on the board or whatever, anything, or they're just being moved, you can always put them back where you find them, as long as they're not internally damaged. Remember, the reason they fly out for the board in the first place is because the low temperature cyberduct solder, it got some of the residue got onto the other components. It makes it extremely easy to melt and extremely easy to come off the board. So in doing so, right now I'm blasting the board with very low heat actually. It's not going to damage any other components. As you can see, every other component is rigid except the part that I'm touching. That's because it has the SMD rework solder on it. And there was a piece of residue of plastic. You see the black part that Teresa was pointing at? That was from the coil. It kind of got stuck on the board. It's not part of the board. To clean it, you can, if you do burn the plastic on the coil and then somehow got sticky onto the board, you can choose to leave it alone, or you can clean it off with a tweezer gently and carefully. Now, in the video, I'm removing an excess residue of the alloy. It's currently on a spot with the really it's just a grounding spot with the heatsink shell it's being connected to. Okay, so the coil, as you can see from the picture now, it's being removed. And moving on to the backlight IC, you want to get some of the CyberDock SMD rework desoldering alloy. There's two types. One is leaded, which is the one I'm using. In my opinion, the leaded one works better. The other type is lead free. It melts at a slightly higher temperature. Instead of being 58 degrees Celsius, it melts at around 70 degrees Celsius, and that's the lead free one. You can choose either one. It really doesn't really matter, but I just personally prefer leaded one, as they are cheaper. So the technique is pretty much the same thing. You put a little bit of desoldering alloy on one side, and you put a little bit of cyberduct desoldering alloy on the other side, and you heat out the component. Since this component is relatively small, it should be easier to remove. This is the backlight IC for iPhone 5. Just need to heat out one side and heat out on the other side. And as you can see, the IC was removed with my soldering iron earlier. Okay, so this is a backlight coil for iPhone 5. You can purchase the coil through the link below, cyberduckllc.com, from our web store for iPhone 5 backlight. So these coils are new, and I'm going to be installing them momentarily. So I decided in this repair to install the backlight IC first, simply because due to its location and size, it's easier to install. Well, it's not easier to install, it's actually more difficult to install due to its location and size. And that's probably why I choose to do it first. Because if you put a coil in, it will obstruct the view, the field of view where you're doing the repair for the IC. And it will also act like a giant heatsink next to it to prevent heat transfer. It doesn't really matter, to be honest, like either one you want to do first, but it's just easier to orientate the backlight IC. Oh, by the way, this IC has priority. So you want to align the line to be the correct orientation, as you can see in the video. basically what I'm trying to say is it has a this IC chip is directional. It has a direction. You cannot install one way over the other. It has a proper direction where it's pointing at. And to help you orientate yourself, it's an arrow. There are lines on the chip that will point to. You want to match the lines to the right direction. It wouldn't work the other way around. The coil, however, is bidirectional. You can install it whichever direction as long as it fits on the board, but not the IC. And you want to use a very fine-tipped tweezer. Ideally, you want to use 2 of them. In this video, I used the pick instead of a tweezer. I don't know. I like the pick better. But it doesn't really matter. If you have a very fine tweezer, then it will work just the same. When you first buy the tweezer, the tip is very fine and pointy until you damage it, and which is all I did in my tweezer. Because you sometimes drop it or whatever reason, get bent, and then you just fire it down back to its finer tip. Again, the orientation of this chip is very important. Also careful when you use the flux. As you can see, like I have trouble figuring out which direction this chip is right now, due to the flux. It's washing and erasing the drawing on it. So I'm guessing at this stage I'm deciphering which directions the IC is pointing. Okay. So you see that in the picture? There's a marking on the chip. You want to point the white line to the other side of the coil. So you want to point the white line to the other direction from the backlight coil. And that will be the direction for the IC. And one good thing about the tacky sticky flux that you use instead of being liquid, it's more sticky. So when you place the components onto the board, it stays on the board due to its viscous stickiness. Okay, so you place the components onto the board, and then you just gently heat up the board to about 200 degrees Celsius will do it, because the solder residue mixture you have on the board is really CyberDuck SMD desoldering alloy, and that alloy, it melts at a much lower temperature, hence you don't need a lot of temperature to solder stuff on. Soldering things on is really the easy part. Taking stuff off, that's the difficult part of this repair, especially with the backlight coil since it's so big. I really recommend you to use a preheater or at least heat out the board. So yeah. But putting stuff on, it's really fun. It's really easy actually. Just heat it up. Don't make things burn. Heat up to 200 degrees Celsius. As long as you use the correct soldering alloy. And just move the component around. You want to get a little bit shear stress onto the joints, so the bond forms better. And you want a good connection between the solder and the metal connection, the copper connections on the components. And that's it. This is pretty much down soldering. I'm just messing with it too. In the video, I'm just moving things around to get the joints perfect. I don't want any cracked solders. for this. Yeah. And the reason I can move the other two components because they also have the CyberDock alloy on. The other components are rigid. Any other component, I should say. As the heat is really not that high. It's really only 200 degrees Celsius. Probably less. You don't really need 200 degrees to solder this, but 200 helps. Okay, then that concludes the repair of the iPhone 5 backlight coil and iPhone 5 backlight IC. You're not done with the repair yet. There's also 3 really teeny small backlight filters on iPhone 5. Instead of being traditionally 2 on all the iPhone models, iPhone 4, iPhone 4S, iPhone 3GS, iPhone 5 is the first iPhone that has 3 backlight filters. I'm not sure why. 2 of the filter has pretty much the same function. I guess 2 of them are both going in, so it supplies ample amount of power to the LED screen. But if you take one out, you only have the screen light. So I guess the reason they have 2 is because you have 3. One's for ground, 1 goes to top of the screen, the other one goes to the bottom of the screen of the LED light. There's 2 LED light on iPhone 5 screen, by the way, due to its longitudinal size. Okay, so now you're just looking at, we're gonna move to the filter parts. And before you do that, always, even if you use no clean flux, always clean your flux off the board. What no clean flux means, it simply means that it has low residue. It doesn't really mean you don't have to clean it. It's always good practice to clean it. It's a technical term, no clean. It's not a literal term. It just means low residue flux. Instead of being like chunks of solid left over, you get liquids. Yeah. And also it means it's not it's electronic safe. It's relatively non-corrosive. So if you do live on the board, trace amount of it, it's not gonna do any damage. Then that's what no clean means. Okay, so now you want to locate the 3 backlight filter. You can go on, if you have difficulty seeing in this video, at least at the moment, go on to website cyberduckllc.com and you can find a detailed in large size of picture showing you the location of the 3 backlight filter. Also, if you are also a member of our solution website, iPhonebacklight.com or whitesoiltesla.com. You can also get the same solution picture and many other more solutions that's not available through our web store because we haven't gathered all the components for the solutions, that other solution that's being made, and also certain solutions and many solutions do not require component exchange, simply require understanding of the circuitry. Then those solutions are only exclusively available to the members of iPhone Backlight community. You basically you have to sign up to access it. Okay, so let's get started with the iPhone backlight filters. There's one over there. And again, desoldering it's very easy and very difficult if you don't use the CyberDock desoldering alloy, because this component is so small. If you're doing it with a heat gun, chances are you're gonna make everything else fly. If you're using a soldering iron, chances are you can rip off the pad because of the heat required to desoldering it. So without actually heating up with the desoldering alloy, I really don't know if there's an easy way to do this. Unless you have a soldering tweezer, then that could make things different. But not everybody have a soldering tweezer. Even with soldering tweezer, you need to be careful not to rip the board off. So for small component like this, it's simple. You just put a huge chunk of, well, relatively thin, since this is so small. If you put a chunk of the alloy on top of the component and put the soldering iron on parallel to the component and heat it up. Oh, again, always use flux. It makes your life so much easier. Without flux, you can't do any soldering. And also careful where you buy the flux. You want good quality flux, and don't buy stuff from China, unless you found good quality flux from China. I haven't been able to. It doesn't. Oh, also I should note, it's not where you buy the flux. It's really what's inside the flux. You want no clean electronic grade flux. Not all no clean flux are electronic grade, meaning they have strong inorganic acid in it. It can corrode the board. The flux I'm using, it's weak organic acid. It's very weak, so it's not corrosive. Okay, so this is, I removed the first filter. This is the second filter you want to remove. Again, you just tease it out, heat it on one side, heat it on the other side with the alloy. iPhone 5, you really need to be careful of how you're removing the filter. Putting it back on is really easy, as you can see later. Getting it out, the reason it's difficult is because you have so many neighboring teeny components right next to it. You don't want to damage any other ones. And you also don't want to damage the soldering pad. So please get some of these alloy when you do this repair. Well, if you buy the entire kit from us, we usually include enough alloy for you, CyberDuck desoldering alloy for you to do this repair, and many, well, probably 5 times or 10 times the amount of quantity you need. So you should be good. If you don't have it, get it. Otherwise, I don't know how you do this repair. If you figure it out easy and safe way to do this without the alloy, let me know. So the downside of the alloy is that you have to be careful not to get this all over the board. But if you use a very small amount, you should be okay. And flux really helps. Otherwise, this will be all over the place. You don't really need to worry too much about this alloy being sticking permanently onto the neighboring components. As long as you don't actually heat up the neighboring joints, like here, it's not gonna remove. And as I was just talking, a dirt filter is being removed, as you see. Like it was just removed of the solder ball. So 1, 2, 3, all 3 filters are removed in this picture. This is the location of one of the filter. I'm tinning the pad, making the pad ready for new filters to be put on. That's the location of the second filter, tinning the pad. And a little above that, it's the location of the dirt filter. They're all the same size and same specs. Yeah. So you don't need to worry about mixing them up because they're all identical 3 filters. You want to make sure the solder residue on it is nice and attached to the copper pad underneath. Otherwise, you're gonna get solder crack. So you see where this is going? I'm gonna place, I'll clean it first, obviously. I wanna place the filter onto 3 filters onto the proper location. And then just heat it up. and you're done. I personally like to use a toothbrush to clean my board, especially the Sonic Care toothbrush. So that's what you see in the screen. And to clean the board, you just need a little bit of isopropyl alcohol or ethyl alcohol if you have some available from any laboratory really. Or rubbing alcohol isopropyl will be fine. It's just ethyl alcohol smells better. Okay, let's get started. Now the pads are cleaned and cleared. You can place the new backlight filter for iPhone 5. 3 of them. Placing filter number 1. It just needs to be. It doesn't need to be exact location, but it just need to be approximately attaching to the solder pad. The heat will do the rest. Oh yeah. Always invest on a very good high quality microscope. The microscope you're seeing in this video is not as the very best quality of microscope I'm currently using. This is the older generation of microscope I was using. It's not as good as making a picture. It was usable for soldering, but it just really can't compare with the newer microscope. This video was made almost half a year ago. I just never get a chance to narrate it and upload it. So it was probably last year I made this video. Yeah, I've just been really busy. Didn't get a chance to upload most of my videos. Okay, so this is the second filter. Again, always use flux. It's better to use tacky flux in this one because otherwise it's not gonna stick. Or if you prefer liquid flux, you could use liquid flux too. Both flux is available on cypher.llc.com. Filter number 2 in place. So one more. Filter number 3. Filter number 3 in place. Now the easy part, heating. Switching on your soldering hot air gun, soldering station hot air, to 200 degrees Celsius at medium speed. And just heat it gently from above the top. Don't do it diagonally, because if you do that, the filter moves, as you can see. Now I have to reposition. I'm doing in the video. I'm holding the higher gun in a slight angle, mostly because it's otherwise it's gonna be superimposed with the microscope view, and that's why the filter move. Otherwise, you do this right perpendicularly on top of the board to avoid the air force to push away the filter from the larger board. Okay, that's pretty much done. Rest of it is cosmetic. You want to make it pretty. All 3 filters are soldered in place. Oh, I guess one of them got loose, the neighboring component. This is why you need to be very careful when you unsolder these and soldering it. But it's okay, as long as you have the tacky flux or any kind of flux, and your airspeed is down low, the component is not going to fly out too far. You can always put a backlight on them. The one that fly off would just happen to be a capacitor, which is fine. You can lose. There's like 5 of them, or 3 of them, as I can see. You can lose those capacitors. They don't actually do anything. They, however, do mess you up if you have a blown capacitor. But if you have a missing capacitor, that's fine. Nothing will happen. Okay, so you're done. You're just making sure the capacitor is back in place, the filter is back in place. They look cosmetically appealing. They look okay. Alright, I'm happy. Orderly as you like. And that's it, you're done. In this video, so far I show you how to use the CyberDark desoldering alloy SMD rework kit to unsolder iPhone 5 backlight coil, backlight IC, and backlight ×3 filters. Once you're done, let it cool off, drop a little bit of alcohol on top, and clean the board. Always clean off the flux you use. Especially next to a connector, you don't want those flux next to connectors. Now examine with a pin, gently push, not too hard, gently onto the components and make sure they're not movable. They actually solder onto the board. And examine your board, checking if the filter is, the backlight IC is being soldered in place correctly, all good, solder joints are stable. Coils are good. Clean your board one more time. This is really for the camera. I don't really have to do this over and over. This is a tutorial after all. Okay, thank you very much for watching. This will conclude the repair for iPhone 5 backlight. You don't have to do these in order. You can change the backlight filter first and then change the IC and change the coil. You don't have to do all 3 of them at the same time. You can change the filter first, see if it works, change the coil then, see if it works, then change the IC, see if it works. If you want to save time, just do all 3. Otherwise, if one of them it's not completely failed, if half failed, it could short off the other one, especially the coil. If it failed halfway, it can seriously damage the other 2. By other 2, I mean other 4. 3 filters and 1 IC. Okay, thank you for watching. I'll see you next time. I almost forgot. If you're wondering where to get the backlight coil, this is the iPhone 5 backlight coil. You can get it from cyberdarkllc.com. This is the iPhone 5 backlight IC used in the repair. You can get new ones from cyberdarkllc.com. These are the backlight filters for iPhone 5. 3 was used. You can get new ones from cyberdarkllc.com. They usually are sold in a kit with all the components included with the alloy required. Okay, thank you. See you next time.